Students, in this class we are going to discuss about working principle of triode. Triode means it is a device, it has three terminal. First terminal is anode, second terminal is cathode, the third controlling terminal is known as grid. So this is a symbolic representation of or actual representation of triode. So this grid is not a metal plate, instead of a flat plate it looks like a spiral. So now the cathode is heated up by using heater. So due to thermionic emissions, the electrons are generated or emitted from the metal cathode. So initially the triode acts as an on switch. If it is on switch means all the electrons are moving towards the anode, or all the electrons produced by the cathode is attracted by the anode, because anode has positive potential, so it will try to attract all the electrons. So almost all the electrons are flowing from cathode to anode. Suppose if I apply positive potential to grid, what will happen? So here there is no electrons or there is no space charge near the cathode. So 100% of the electrons are attracted by the anode. So it is completely on if I apply positive voltage to grid. It depends upon the magnitude of the positive voltage. So here we assume that there is no grid current, or there is no absorption, electron absorption in the grid. So if you assume that, then there is no space charge in the cathode, all the electrons will be attracted by the anode, because anode is positively charged, the electrons are negatively charged. So these negatively charged electrons are attracted by the anode. So 100% electrons are flowing from cathode to anode. So initially, so if I heat the cathode, these electrons, space charges are produced, but instead of positive voltage, if the grid is connected with the negative voltage, now what will happen? The grid has negative potential, the electron has negative potential, but the magnitude of the potential is only -1 volt. So part of the electrons will be repelled by the grid. So only 10%, 90% of the electrons are reaching the anode. The other electrons are repelled by the grid. So some electrons are repelled by grid voltage of -1 volt. Instead of -1 volt, if I apply -2 volt, what will happen? So here almost 50% of the electrons are repelled by the grid. The remaining 50% of the electrons are reaching the anode. So here instead of I am saying 50, but now it is 20% electrons are repelled by the grid. If I apply -3 volt, what will happen? 50% of the electrons are repelled by the grid, and the remaining electrons are reaching the anode. If I apply -4 volt, what will happen? 75% of the electrons are repelled by the grid, and only 25% of electrons are reaching the anode. If I apply -5 volt, then almost all the 100% electrons are repelled by the grid. It is completely closed, so no electrons can reach the anode terminal. It is completely blocked by the grid. It is like a gate opening in a pipe. So what are all the parameters? Now if I apply a voltage, what will happen? There will be a flow of electron from cathode to anode, so there will be a current flow. So this is known as IAK. IAK means anode to cathode current. The electron flow direction is from cathode to anode, but the conventional current direction is opposite to electron current direction. That's why I have shown the arrow like this, IAK. And one more potential is VG. VG means it is a grid voltage or grid potential. And the voltage across anode and cathode is represented by VAK. So this triode is an ancestor of a transistor. Your anode is known as collector, your cathode is known as emitter, because it is emitting the electron, and grid is controlling the electron flow. So grid is known as base. So next lecture we will discuss the history of transistor in detail, and before that, this is the characteristics of vacuum triode. If there is no grid voltage, then all the electrons are almost reaching the anode. If I increase the grid voltage -0.5, 1, -1.5, 2, -2, -2.5, -3.5, the current is decreasing. So that next class we will discuss the